Good morning, everybody. Welcome to another episode of Coffee Hour. My name is Paul Abernathy. Welcome to Tuesday morning, the 7th of January. Can you believe it? We blink. We had New Year's, and I remember it. And all of a sudden now we're 7 days into the year. So that should tell you that time does not wait for no man. It continues to click by. So make sure if you have any dreams, things that you plan to do in 2025, don't sit back before you know it. The year will be gone and we'll be celebrating 2026. So life is short. Achieve all the dreams you can. And if you're looking to get into business, start your own business, create a side hustle that helps support your family, all those type of great things. There's no time like the present to get started. Do not delay. Okay. We are never guaranteed that we're going to wake up in the morning. The sun's going to come up, but we might not wake up. So again, make every day precious. So I'm excited today. We're going to talk about the secondary conductors 25-foot rule and kind of look at that. And we might jump back around and look at another rule, whereas it's the unlimited feeder tap rule. We might jump and look at that as well today if we've got time. If we get through the 25-foot secondary conductor rule for transformers, which I'm sure we probably will get through it pretty quickly. But that's our agenda for today. Of course, as always, let me know where you're from and if you're in our program and things like that. We'd love to hear from you. So again, we've got Red Dog out here this morning. I believe California, still coming in. We got Paul. Good morning, Paul. Thanks for joining. So again, folks, wherever you're from, let us know. We'll share it in the comments, and we appreciate having you. Now, for me this morning, I got my normal cup of joe, and in our mugs that we have over on our website, fasttracksystem.com, if you're interested in that. But we got snow last couple days here in Virginia. It's about 6 inches or so of snow. The roads are treacherous. So all my electrical contractors out there that are in the area where it's impacted by this recent snowstorm, okay, if you don't need to get out today, don't go. Stay home, chill. Watch a little TikTok, YouTube, watch a little video, spend time with the family. Call in for a sick day. You know, I know electricians never do that, right? But at the end of the day, those roads are nasty if you're in the area that's affected. I can tell you right now, I ain't going nowhere. So let's see here. What's up, Jay? Good morning from Florida. Nice, probably nice weather down in Florida. It is not so much here, okay? Not so much here in Virginia, okay? At least where I'm at, over near the eastern side of Virginia. So, at any rate, okay. All right, so we're going to get into today's topic. Before I get started, I do need to give a shout out to some folks that emailed me last night, and they wanted to know where do they go to get the coins. And I got it. It came in late, so let me tell you in case you're watching. If you're talking about our engraved coins, just a conversation piece. The individual was asking about my inspection coin, the pass-fail one. You go to our website, you'll see it. It's in our store, and it's under products, and it's the engraved products. Not the easiest website to navigate when it comes to those products and all that type of thing. So, but again, it is over in our store over on the website, and that's where our engraved stuff is at. That's where the wallets and all the other stuff. If you're interested, that's where it would be located. Okay. All right. I answered that question for somebody. Also, I am getting an awful lot of the Let's Ask Paul. So from time to time, I might share one or two of the Let's Ask Pauls here in the morning in coffee hour, so we can answer those questions. So if you have a question that you want me to answer in coffee hour, we'll probably start that up. So all you got to do is, a lot of times I answer them in emails and in podcasts. But if you have one and you want me to answer, then all you got to do is just send me an email of your question and ask me to answer it on coffee hour, and I will do it. I will do my best to keep your name anonymous, but again, I can make no guarantees on that. It's just a question. It shouldn't matter, right? So just go to paulabernathy.com if you want to send it. And if you want it to be shared on Coffee Hour, then let me know. And what I'll do is I'll respond back to let you know that your question will be answered on Coffee Hour. That way you know that type of thing, right? Okay. Let's see here. We got some morning. Dan, good morning. Welcome. So, all right. So today we're going to get into the topic. We want to look at the code when it comes to dealing with the secondary conductors, right? That type of scenario. And I wanted really quickly also, let's see if I can't find it. I wanted to show, just to get an idea of what we were doing here. Hold on here. Let me check something real quick and see if I can't find an illustration that I want to be used for something that I'm doing here. Let's see here. Hold on here. While we're waiting, while I'm looking real quick, I know I'm not real organized, but again, I don't get real organized for these morning sessions. I just talk with, it's just a conversation between us. So let's see if I can't find what I'm looking for. That is not what I'm looking for. Bear with me. Got any questions? Please put them in the comments. I'm more than happy to try to address them if they're there. Let's see here. I think I'm in the wrong course. Hold on here, folks. Let me get to the course I should be in. Bear with me. As I'm winging through this morning session, again, this is your opportunity to let me know anything in the chat if you want to. I'm more than happy to address it. If you have a question, I'll do my best to address it while I'm looking for what I was looking for. Let's see here. Trying to find my topic that I was looking for. Okay. Good enough. Picture I can share with everybody. All right. Okay. All right. So let me get into it. So what we're talking about today is the 25-foot secondary conductor rule. And this is where you are supplying a transformer, and now you have the secondaries that are coming out of it. How far you can reach? How far can you go where the conductors are considered connected to the secondary side of the transformer? Now, the transformer protection, if we have a primary that goes up to 125% protection on the transformer's primary, the secondary is up to 250 on the primary, up to 125 on the secondary. Well, this typically is going to culminate into an overcurrent protected device more often than not. And in this case, the conductors are sized to equal to or greater size of the conductors to the overcurrent device that it's connecting into, right? So you have specific rules that we have to follow. And if we have to protect the primary, we have to protect the secondary of this transformer. Although we saw in previous episodes, we could have primary only protection under certain conditions. But if we're going to go up to 250% on the primary, which again, is not the norm, but you can. Most people just do 125 on the primary. That way the conductors can be at 125 and everything's protected. Not only the transformer, but the conductors itself. But on the secondary, you have these rules, these tap rules. Now, could I go straight from the transformer and hit a breaker, like a disconnect, and then from there have my conductors? I think we answered that for yesterday. I can't remember if that was for Dan. Then my conductors basically act like feeders, and they can go any length they want. They are on the load side of an overcurrent device, so they're technically would be feeders. In that scenario that we talked about, then their length isn't limited. But that's because it's on the load side of an overcurrent device that's actually protecting the transformer, and there's conductors between the transformer and that disconnecting means. Okay? But what we want to talk about is the rules for us to be able to have secondary conductors from a transformer and have it be able to go all the way up to 25 feet. Not the most common because most of the time, most transformers I see, the panel that it's supplying is fairly close to the transformer. It's not really far away, that type of scenario. But it could happen. So what we're talking about is kind of just an example. What we're kind of talking about is these conductors right here. Right here. These right here. This portion of the transformer is what we're talking about. Okay. Now this was part of our other lesson that we did where you have a feeder tap that is being tapped in order to supply a transformer. And this was talking about the overall 25-foot combined length rule. We talked about that in another video, another coffee hour. But what we're talking about today is these length right here. Okay? Now those conductors are the secondary conductors, and this would be 240.21C6 right here. These secondary conductors. So we went over this rule. This was the 10-foot rule. Okay? We went over that rule. I think it was yesterday's coffee hour. So if you haven't seen that, go back and watch a previous episode. And now we want to jump to this one. And be honest with you, if you hit the transformer and you're coming up to the secondary, usually the secondary conductors are going to terminate in some type of equipment right there next to the transformer. And then after that, again, you have your circuits that can go out and wherever you want them to go. That's not an issue. We're only limiting the distance on these secondary conductors, that type of thing. All right, so that's what we're talking about here. So now somebody did ask a question about, well, when can these secondary conductors be unlimited in length? When can we have an unlimited? And we will be talking about that, but there is outside secondary conductors, okay? And they still have conditions to meet, right? But you'll notice there's really no length limitation on those. But that's because those conductors are what? They're outside. They're not inside. Not acting like a big old, something that if it were to burn up could cause problem with the building. These are outside of the building, right? So these are not an issue. But we're not talking about those today. We're going to focus on this rule here today, right now. At least get this one out of the way, and then we'll see where it goes. If you have any questions in the comments, feel free to let me know. All right, so just so we have the context of what we're talking about, this is our topic right here. Just this is where I'm circling. We're talking about these secondary conductors, the length. Okay, we saw the 10-foot rule the other day. Now we're going to the 25-foot rule for those secondary conductors. Okay, what are the rules? It says, well, where the length of the secondary conductor does not exceed 25 feet, and complies with all of the following. So in order to get that 20-foot length from the secondary side of that transformer, to get all that 25 feet advantage of this conductor length, we have to follow these rules. Okay. The first one says, the secondary conductors shall have an ampacity. Okay, so it's telling me we have a minimum ampacity requirement here. Shall have an ampacity that is not less than the value of the primary to secondary voltage ratio. Okay, so we kind of did that in an example the other day. So in order to get the primary to secondary, in this case, if it was a 75 kVA transformer and we have 480 primary and 208 120 secondary, typically delta primary, 208 Y 120 secondary. In that scenario, the primary to secondary voltage ratio is just primary divided into the secondary. So 480 divided into 208. And that gives me 2.307, and I can round this to 2.31. So that is my ratio that we're working with. And then it tells you to multiply that ratio by 1/3 the rating of the overcurrent protecting device protecting the primary of the transformer. So let's say we had 125 amp primary protection. Okay, let's just say that's what we had. And that's what we would have with a typical 75 kVA transformer, and we're protecting the primary side, and we're just going to do everything at 125. Okay, so in that scenario, we have to have 1/3 the voltage. We have to take 1/3 of that overcurrent protected device. So that is 125. Just throwing numbers here, and you go 125 divided by 3. That is 41.66. Okay, so I'm going to keep that 41.66. I'm going to multiply 2.31 times 41.66, and that gives me 96.23 amps. So I have to have a conductor, okay, on that secondary, first of all, that has to be at least 96 amps. Now, you and I both know there's more to this than just that. At least has to be that size of conductor. So that's the first thing, okay? Well, next thing we look at is okay, it says that secondary conductor has to terminate in a single circuit breaker or set of fuses that limit the load current to not more than the conductor ampacity that is permitted in 310.14, because we have adjustments, corrections, other things that can take place in 310.14, which ultimately sends you to things like 310.15, B2, B1 or C1, things like that. And you could have ambient temperatures. You could have something, but it means that conductor's ampacity may have to be adjusted in some way or corrected in some way, right? And so again, basically it's telling you that it has to terminate into a circuit breaker, or it could be fuse set, okay? And that fuse set has to limit the current to not more than conductor's ampacity. Well, we already know what the minimum of the conductor's ampacity is, that type of thing. Now, for us, we know the chances of finding a conductor that is exactly 96 amps is not going to happen, so we pick a conductor that can at least handle the 96 amps, okay? All right, and then at that point, we're going to be going into the panel, and we have to make sure that that overcurrent device is going to be limiting the current to whatever the ampacity is of the conductor, right? Remember now, we're not able to use the next size up rules. Why? Y'all remember what we saw earlier, the general rule up here, or we saw the other day? When it comes to this transformer secondary rules, right here it says section 240.4b shall not be permitted for transformer secondary conductor. So we can't use a next size up rule for this. Now I will say for this 25-foot, a lot of this is also going to be dictated by whatever my load calculation is. So if you're the engineer and you're designing this, for example, you're going to be picking a transformer because you know what your loads are going to be. So if I'm picking a transformer like a 75 kVA transformer, and I'm trying to find out what the amps are, the output amps on this thing, what can happen, how many amps do I have at the secondary, and it's a 75 kVA, well, since it's a 208, and we know to go 208 times 1.732, which is square root of 3, that gives me 360.256. So let's say 360.26. So I'm going to take that 75,000. I'm going to divide it by 360.26. And you could just use 360. Going to get you close enough in the field. That is 208 amps. So I'm probably going to be terminating this into a 200 amp panel in a main breaker. Okay. So I still want to utilize this 25-foot rule. All that we saw with the rules here first was that we know that the conductor itself, based on this rule, has to have at least 96 amps. Well, that's not going to be an issue for us. All right, now, that might be an exam question that asks you, what the minimum size secondary conductor is for a transformer, and they give you the size of the transformer and the voltage and all this kind of stuff. But they might ask you what the minimum is. You've got to remember something. Just because a transformer can put out 200 amps doesn't mean I have to size it to 200 amps, right? A lot of people think that that's always the case. Well, I could have two separate 100 amps being supplied by this transformer. I could have two separate secondary conductor sets coming out, supplying two separate 100 amp panels, and still would be well within the scope of that transformer. I also remember that there's nothing in the code that says that I could not put a 300 amp panel on the secondary side of that transformer. The panel might be oversized and things like that, and you're going to overload and overdrive and shorten the lifespan of your transformer, right? But nothing says that I can't do that in the code. It doesn't limit me that. But the moment that I do that, then the conductors have to be sized what? They have to be sized for that overcurrent device that they're connecting into, right? So, but as far as a minimum size rule, then we have to make sure that our conductors are at least is size based on the calculation. They're at least that size of conductor. Okay. All right, let's go to the lesson here. All right, back here. All right, so they shall have an ampacity that is not less than the value of that. We already did that, so it can't be less than that. Sweet. Probably going to be larger than that, depending on the load that we're trying to serve. We get it. This is minimum rules. And as the secondary conductors, they have to terminate it into a circuit breaker. And again, if the load, right, is the load of that panel that we're supplying is a 200 amp panel, and our transformer can handle that load, then we're terminating into a circuit breaker that's 200 amps. Okay, well, then it says a conductor, okay? We can't have the circuit breaker. It has to protect the load, okay, and not more than the conductor's ampacity. So if we're going to have 200 amps, then we need to increase that conductor's size. So this ends up being a minimum. And then, of course, we have to be aware of these rules, depending on what load we're trying to serve in that panel. And then lastly, it says the secondary conductors are protected from physical damage by being enclosed in an approved raceway. Approved means whatever your AHJ is happy with, whatever they think the approval is okay with, it still has to be a raceway. And raceways are something that we know are things like rigid, intermediate, conduit, EMT, PVC. All these things are raceways. MC cable is not a raceway. It may walk like a duck, quack like a duck, but it's not a raceway. But then you get this or, and then it says by other approved means, and your AHJ, depending on the location where it's at, maybe they work with you and they do not have a problem with the MC cable. Although I will tell you, the MC does not provide any physical damage properties. In other words, if you look in the 330, uses permitted and uses not permitted, you'll see that you can't locate MC where subject to physical damage, no different than you could a non-metallic product, like a cable, like SE cable or NM cable, things like that, tray cable, that type of scenario, okay? All right, it's pretty simple, pretty straightforward when it comes to those secondary conductors, okay? But again, remembering this is a minimum, and depending on the load, we said this was a 75 kVA transformer. So I'm going to get 200 damn amps out of that. That 96 amps minimum size conductor ain't going to do squat for me. So I'm going to end up increasing my conductor in order to get what? In order to be able to terminate it into whatever device I'm terminating to. And I need to make sure that that conductor is protected at its ampacity, right? Okay, so they kind of works together, if you will. Let's see here. Good morning, sir. You've been monitoring my classes while Swartzy works. Well, thank you. He's a worker now. Ain't no doubt about it. Ain't no doubt about it. Glad to have you here. What's up, Frank? Thanks for joining me. Thanks for joining. TJ, I see you in there. Good morning. Thanks for joining. Love to have you here. Okay. Tell Swartzy I give him my best that I'm going to, we have to collaborate on something, but he's such a busy guy. So anyway, he is also a great guy. All right. So next thing I want to go on, let's go on in while we're doing this, and we got plenty of time. We went through that one fairly quickly. Let's go on and look. Let's go back to 240.21b, and let's go on and tackle this one here again, which we covered in a previous episode kind of loosely, but we want to make sure that we cover the requirement. You know what? We did cover that one already. Let me make sure. Let's cover. Hold on here. Let's cover this one. So this is, let me make sure I'm still in B real quick. Hold on, folks. Yes, I am. Okay. Let's cover the outside one and get that out of the way right here. So this is 240.21B5. And again, jumping back and forth between secondary conductors. And now we are back to primary. We're back to primary. We're back to feeders. Okay. So we're talking feeder taps now. So we shifted gears from the transformer secondary, which previously we talked about the 10-foot secondary. Today we covered the 25-foot application when it comes to secondary conductors. Now we're jumping back to feeders. And again, some people will say, it's so confusing, Paul, you're back and forth, but that's the whole purpose. That way, somebody coming to the video doesn't just come for one topic. We cover multiple topics, that type of scenario. And I probably should put timestamps on the videos, but I'm too lazy to do that. So I'm not going to timestamp it. You just got to watch the video if you're coming in after it's been already recorded. All right, outside. All right, so this is where a connection is being made to a feeder, and this is outside of the building, okay? What we consider outside of the envelope, okay? It says where the conductors are located, and they're talking about the taps, where the conductors are located outside of a building or structure, except at the point of load termination. I mean, obviously they have to come back into the building if it's a tap connections made outside, which is very common to make these connections outside in big buildings. Now it comes around the building, but it's obviously got to get into the building to get to a piece of equipment, right? Whether it's the panel, whatnot. So obviously the outside portion of this taps, they're going to cover the outside, not the portion that immediately comes in and has to terminate. And we'll see rules on that, okay? When it tells us about the termination and stuff. It's going to be very similar to the rules that we have, for example, for services. 230.70, outside or the nearest point of entry, okay? Once those conductors come in, those tap conductors come in. So, and it tells us it has to comply with all the following conditions. So let's set the tone here. We're talking about equipment outside. You're making a tap to a feeder outside. Maybe it's running around the building on the outside in a raceway. And then all of a sudden it gets to where it needs to come in to a building. Maybe it's a separate occupancy. And boom, it pops through the wall. That's what we're talking about. But it's outside. The tap conductors are outside the building. All right. Number one, the tap conductors are protected from physical damage in an approved manner. Now, you do see that this runs all over the place, folks. Whether it's the 10-foot rule, whether it's the 25-foot secondary rule, whether it's the feeder tap rule. Some say an approved raceway, some say whatever. It goes all over the place. So there is no defined uniformity to this. I would hope maybe that somebody would submit that, and I never thought about it, to the code making panel to try to bring unity. What do you want? Do you want the conductors in an approved raceway, or just is it okay in an approved manner? Again, this one probably is a little more lax because it is outside of the building. Okay, but approved manner to me just opens it up and just says, hey, the AHJ can say, I'm all right, I'm okay. It's whatever you want to put it in. Okay, it's fine. But I like it to be a little more defined, like a listed wiring method or a listed raceway or something like that, rather than just an approved manner. Okay, now some people would like that. They say, look, I just like giving the AHJ options to approve an installation. Okay. Well, maybe that's the way you go with it. I'm neither here nor there. I'd like to see something more, specific, if you will, but like damage because there's only certain things that physical damage qualifies to be protection, like Schedule 80 PVC, rigid, intermediate, things like that. EMT now is designed to protect from physical damage. It wasn't a couple cycles ago, but it is okay now. Those type of things. All right, so that's the first thing. So work with your AHJ, whatever. You put it in rigid or intermediate or Schedule 80 PVC, then you ain't got to worry about an argument. Next, the tap conductors terminate in a single circuit breaker or single set of fuses. Again, we see the same language that is going to limit the load to the ampacity of those tap conductors. Okay, so whatever the load is in the calculation and whatever the size of those conductors are, the overcurrent protection has got to limit it so that those conductors will not see more current. Okay, they won't see more current than the overcurrent device limits, allows at the point of termination. Okay, so you have to correspond. If it's a 200 amp overcurrent device, then it protects a conductor, and those conductors would have to have what? An ampacity that is going to be protected by the overcurrent protected device, right? And remember, these are taps. So the moment that somebody hears that, they go, well, good, that means I can use the next size up rule? No, it's still a tap. And you remember the general rule says you can't use the next size up rule. So get that out of your head. So it's automatically going to be equal to whatever the overcurrent device is it terminates, because you have to make sure that it has the ampacity that is going to be protected by the overcurrent. It says it right there. Okay. Next, it says the single overcurrent device shall be permitted to supply any number of additional overcurrent devices on the load side. So that means it could hit a main breaker and then you have other overcurrent devices on the load side. That's perfectly fine. Or you could hit a single main disconnect, right? And then it has additional overcurrents on the load side of it, and that's fine also. Doesn't matter whether they're together in one cabinet or two separate cabinets. It doesn't really matter. And I had an illustration I could show of that, but that's kind of what we're talking about. All right. Next is the overcurrent device for the tap conductors is an integral part of a disconnecting means or shall be located immediately adjacent to. Okay, so let's see if we have no illustration. Okay, so again, if you have a panel with just breakers in it and the disconnect's right beside of it, that's fine. Okay, not a problem. Locate immediately adjacent means right next to it immediately. So if the room is there, the space is there, you can't just choose to go put the disconnect down the way. If it's right there and there's room to put it, then it needs to be immediately adjacent the additional overcurrent devices. So that would be like your disconnect. If you just want to go separate disconnect and then you have a panel like a main lug next to it with all the breakers in it, that's fine. You just can't put the main, the one disconnect way away, okay, that those taps terminate into. Okay. Now the reason for this is because you could put that outside and then it feed a panel directly inside, that type of scenario. So it's giving you a little lee room. It could be all in one equipment or it can be two separate, but they have to be immediately adjacent to each other. And I do get a lot of people that argue the term immediately adjacent. They're like, well, what's immediately adjacent when the code says do that? If there's room to put it right beside it, to me, that's immediately adjacent. If I have a 10-foot wall span and I want to put it 10 feet away, and I had plenty of space to put it immediately right beside the equipment, then that doesn't, to me, meet immediately adjacent. If it had said just adjacent to it, but this says immediately adjacent, so right beside it. So that's another example of rules throughout the code that may make reference to immediately adjacent. You have to use your common sense and look at it and go, well, what's immediately adjacent? Well, if here's the equipment and I got room to put something right beside it, then I put it right beside it. That is immediately adjacent. Makes sense? Okay. Should make sense, but again, we have people that want to argue that to the semantics of it in the code, and that's fine. That's between you and your AHJ. Again, at the end of the day, the code is written specifically a certain way. Some people would like it to be black and white in a sense that it gives you every known possible rule, but it is a minimum standard. So you do have to work with your AHJ in many cases to bring finality, because every jurisdiction might look at something a little different. And of course, the code has to be molded, if you will, to different jurisdictions around the country. So what may be applicable to the conditions in Florida may not be the same as the conditions in Ohio or in North Dakota, or things like that. So again, it's got to be flexible in order to try to meet it. And where there's that area in there that people say is gray, I like to say there are areas of negotiation, because a gray area can always be negotiated, and it depends on how good you argue your points, kind of like a lawyer in a courtroom. If you make your points and the other side goes, that's plausible, then you've hit a home run, and now you've negotiated something that everybody can be happy with, right? Okay. All right, so immediately adjacent there. Now, the last one right here, number 4, it says the disconnecting means for the tap conductors is installed in a readily accessible location, okay, complying with one of the following. So again, whether or not it's immediately adjacent to it or it's all in one cabinet, like a normal a panel board enclosure with a main breaker. However, or if it's a separate disconnect right beside it, they're not integrated together. Either way, the disconnecting means that these tap conductors terminate into have to be in a readily accessible location, not just an accessible location. And you all are familiar with readily accessible as it's defined in Article 100. So we're all familiar with that. It's got to be a location where I can get to without climbing over or climbing under. We can't have any obstructions that keep us from being able to get to it quickly, things like that. So it has to be readily accessible. So we established that. And located and complying with one of the followers. Okay, so that disconnecting means is to be either on the outside of the building or the structure. Okay, so outside the disconnect, and of course, then you can immediately adjacent, could be immediately on the other side of the wall. We could argue that. It says inside, nearest the point of entrance of the tap conductors. So the moment that those tap conductors turn and say LB into the actual building, boom, they're going to go right into a disconnecting means. Maybe it's the panel with the main breaker, or maybe it's a separate, as you saw, a separate disconnecting means. That's your choice. And then it says we're installed in accordance with 230.6, the nearest point of entrance of the tap conductors. Now, 230.6 is when we're talking about conductors that are coming in from the outside in any of these applications, like it's in concrete. So you could have the conductors come into a building and then come into a concrete column and then continue on encased in concrete, 2 inches of concrete, okay? And that type of thing. Here's where we're talking about the raceway is encased in concrete, not less than 2 inches. There's other allowances here, like being underground 18 inches beneath the building and things like that. Or we're installed in rigid metal conduit, intermediate conduit used to accommodate the clearance requirements of 230.24 and routed directly through the eave. Totally different rule than just running it into the building and encasing in concrete to say, get to a second floor where this is going to terminate. If you have all those options, but the moment that it emerges out of that 2 inches of concrete, boom, it's got to hit that disconnecting means. So you have other options here to be able to do this, okay? And then there's a good informational note, a good commentary. I gotta be careful with that. It is like an informational note in the link, and it is commentary. And of course, informational notes are not enforceable. So it's like an informational note. Problem is, this is just commentary from whoever wrote the handbook, because this is probably the same info that's in the handbook. And basically, it's just saying the tap conductor requirement is similar in some respects to the installation of service conductors. That is true. Outside nearest point of entry. You remember we talked about it, dealing with 230.70, A1. It says the conductors are supplied from a feeder at an outdoor location and run to a building or structure without limitations on the tap conductor's length. No length. The only other limitation that I can tell you that we would have, because remember, this is all outside. So you tapped outside a feeder and you're running it to a certain location outside. There's no length limitation. There's no 10-foot tap rule. There's no 25-foot tap. It's unlimited. But, there are other considerations that you need to think about. I mean, you're still going to have voltage drop. While voltage drop is not a requirement, whatever you're supplying, it could affect the operation, the life expectancy, or the efficiency of whatever the equipment is. So a voltage drop, while not a requirement, again, is something that most electricians and design professionals will at least take into consideration. But there's no mandate in the code to do that. But it is something, for that anyway. The only voltage drop mandates, as you're aware of, are sensitive electronic equipment and fire pump applications, because we want that fire pump to run. We don't want it to, we want it to burn up. Okay? So we're not trying to protect it in any way, that type of thing. Still got short circuit and ground fault protection on it, but it's going to burn up, that type of scenario. Okay. All right, let's go back here. So, all right, so that's all out of the way. And then it says, the overcurrent protector device provides overload protection for the tap conductors. That's right, because it's coming from the feeder, and it's coming from the feeder tap outside, unlimited length, okay? And again, it has no protection at the tap, right? Wherever it's tapping, there's no protection there, okay? So the overcurrent provides overload protection for the tap. That's why we're required to limit the amount of current that can be on those conductors. You saw earlier, we're limiting the amount of current, okay? So we're going to provide some overload protection there. It says the fuse switch or circuit breaker is installed in a readily accessible location, either inside or outside the building or structure, at the nearest point where the tap conductors enter the building or the structure, okay? If you want to do it outside or nearest point of entry. It says this disconnect is subject to the applicable requirements covered under feeder disconnecting means. Absolutely. So remember, it could be a situation where it's a feeder tap outside and it's actually feeding a whole different occupancy. It might be even feeding one building, and it might have a 2-hour separation, and that feeder tap might be feeding another building. Well, at that point, feeder in all the feeder rules, all the disconnecting rules in Article 225 will come into play. So again, have to be careful about all those type of things. So that's where a lot of people forget that it's a situation where, since it's outside of the building, right, when the tap is made, right, all of the rules for 225, which are feeder rules, come into play. And again, 225 is outside feeders in branch circuits. Okay, 215 is just feeders. This is still outside. It never entered the building. So it is an outside, okay, feeder tap. And it also has to meet all the rules for the disconnecting means that are in Article 225 because it is outside and it's originating from outside, that type of scenario. Let's see here. Good morning, Richard. Thanks for joining. California. Thank you, sir. God bless you too. And Eric. What's up, Eric? Thanks for joining as well. Glad to have you here. All right. Folks, you got any questions in the comments on any of the topics today or anything else that you want to talk about? I'm more than happy to go over anything with you. We got enough time. We actually finished these two in pretty straightforward in record time. So I don't, we can talk about anything that you guys want to talk about, any questions, any upcoming things that you might encounter that you want to discuss. This is, your time to do so. Let's see here. I wonder if there's any one other one we can knock out today as well. We'll talk about this, taps over 25 foot long. Okay, so this is an application where you do have, this is basically, as you can see, this is still under feeders. Okay, and there is an allowance. We'll cover this in a second one, but this is a situation where you have taps over 25 feet. So somebody asked me a question, secondary conductors, I'll show you here. Secondary conductors, we have applications, again, not over 25, outside, secondary conductors from feeder tap, tap transformers. We talked about those again, and then not over. We see a lot of not overs, right? But when you come to the feeders, we do have one here that talks about, I realized I wasn't sharing squat with you. Hold on here. So as you can see, as I was talking about a second ago, here for secondary, for transformers, we see that we have not over 10-foot rule, we have not over 25-foot rule, we have outdoor secondary conductors, which are very similar to what we just talked about for the feeder outdoor, right? We got secondary conductors from a feeder tap, okay? And we have secondary conductors not over 25 feet long. We have those. But when it comes to the feeders, we've got, and we'll talk about all of these, but we've got not over 10 foot. We've covered that. Not over 25 foot. We covered that. This is the one that we talked about, tap supplying a transformer that is the primary plus that it's not over 25 long. And that's the one we talked about in a previous episode, right? And then we've got taps that are over 25 foot long, and this happens to apply to high bay manufacturing buildings, okay? So if you're not dealing in a high bay manufacturer, extremely high bay with high lighting to accommodate larger trucks and larger things like that, then you have some allowances here that you can follow. And of course, this is an illustration that we'll use to show the example, okay, as well. Okay, so this is your height limitation. So we'll show you that, okay? So this is that tap rule, and this has a bunch of rules here. But one thing is that those tap conductors are not over 25 long horizontal and not over 100 feet in total. So there are specific rules for the horizontal portion of this. And we'll cover that in a total separate episode. For those that are taking an exam, I would never worry about this one being on an exam, too many pieces. But any of the other ones are a fair game. And we won't have time to talk about this one this morning. But that, again, that is this one right here. We won't have time to talk about this one. But this is very specific to high bay manufacturer buildings. Okay, so that is very specific to it, that type of scenario. But what you'll notice is generally everything else is 10 foot, 25 foot, outside unlimited. And then, of course, you have an allowance here, okay, for feeders when it comes to high bay manufacturing buildings, which you would have a situation where overall the conductors will be over the 25 foot. Okay, but we'll cover that, and we'll use this illustration by link to show that. Okay, and here you see that the horizontal portion is not over 25 feet, but the overall length is not more than 100 feet. Okay, and it's going to limit the height to 35 feet at the walls. Okay, so you've got these little caveats, and that's a perfect world to be able to deal with that. Okay, and of course, then here's the unlimited outside that we just talked about. Okay, so let's see here. What do we got, Dan? Dan says lower in same area. Lower in same area, there is some rules for industrial areas for taps and secondary. There is secondary rules, and you basically just follow the rules. They're not complicated, right? They're just secondary rules. But when you say industrial, the tap rules are all right here in 240.21C. If they're B and C, B for secondary, C for secondary, B for feeder taps. If they're anywhere else outside of here, then they're not taps. Okay, except for we have branch circuit tap allowances in 210. That we have some there, but other than that, these are your specific tap rules, that type of thing. And here's your 210 allowance for the branch, gives you reference to the branch, that type of thing, right? So I'm not familiar. I'll have to look, Dan. I'm not sure that reference has any germaneness to these tap rules that we're talking about. All right. I don't think there is anything else that we want to cover today with these. I don't see any specific thing in here that's, there are other applications for taps, by the way, just so you can see. Let me go back up here. So this is basically the location. So overcurrent is, so it's in 240, right? So it's really all about where there's overcurrent protection and where there's not. Right, when it comes to the conductors, right? So overcurrent protection shall be provided in each ungrounded circuit conductor. Okay, that's the general rule. We have to have overcurrent protection. Okay, and shall be located at the point where the conductor received their supply. So typically, what we do is we have conductors, and you hook them to overcurrent devices, and they're being protected. So these rules are for kind of allowances that say, you know what, I can tap onto a certain conductor, and I don't have to worry about the overcurrent protection device being located where that tap is. And then the reason we call the secondary conductors for the transformer the secondary conductors, because they are also connecting on to somewhere that does not have overcurrent protection at the point where those connections are made, right? So this is all this is talking about, is the location of where that overcurrent protection has to be. And of course, the general rule is you protect the conductor at the location, the point where the conductor receives its power, right? Where it gets supplied power, which is what we normally would do when we take conductors and hook them onto breakers, okay? They're being protected, and that's why we size breakers the way we do. But there are some allowances, and here's what we've been kind of just dabbling in and looking at the different tap rules, different secondary conductor rules. Is that all that's there? No. I mean, there are applications down here where it says service conductors shall be permitted to be protected by overcurrent devices in accordance with 230.91, right? So we do have some applications for there. And it's also important to remember that in many cases, you're allowed to do certain things like, remember service conductors? So one of the allowances, for example, in a 122/40 volt where we have the service drop coming down, and we typically have an allowance where typically you would say, okay, well, those conductors have to be the same ampacity as the device it terminates into. Okay, well, and they have to have the overload protection in 230. Well, we have an allowance there. Remember to use 310.12, which is the 83% rule. We have allowances there. And so those conductors may not have the same ampacity as the device they terminate to, for example, services. So we have those allowances that we do. We have different things for motor taps that we do. Right? And motor or feeder branch circuit conductors shall be permitted to be protected against overcurrent in accordance with 430.28 and 430.53 respectively. Again, these are tap allowances, but these are specific tap allowances for motor applications only, right? And you have to meet all the criteria. And it, ironically, for this motor feeder tap application, you see that it uses a lot of the same language, 10-foot length, right? 25-foot length, that type of thing. And then, of course, you have some exceptions. Here's that high wall, high bay. So the feeder from motors, they take their own rules in 240.21, and they will modify them to meet that specific condition. Okay, so we start out generally for the tap rules, but under the location of the overcurrent where it can be, it's not just a secondary rule. It's not just a feeder tap rule. You also have additional allowances down here that you have to be aware of. Okay, so just keep that in mind when you're applying it. But for me and you, most of the time, what we're going to be dealing with is, especially if you're exam prepping it, it's just going to be 10-foot rule, 25-foot rules, whether it's feeder taps or secondary conductors, and they basically just follow it item by item. They're going to be pretty straightforward, not too hard to work with. And again, here's an example. If you have a busway and you're tapping a busway, here you tap a busway. Again, it's not going to have overcurrent protection at the tap, so then you have rules that you have to follow. Okay. And there's the B, and there's feeder and branch circuits. Again, you have rules that you have to follow if you're going to make those type of connections, but that is specifically to a busway type of connection. So all of this has to do with the fact that we know that you're not going to be using overcurrent protection at the point where those taps occur. That's what this is all about. And same thing when we did it for the motors. That example for the motors where we say go and look at the motor application in 430.28. It's almost identical situation. You might run a feeder and you're supplying multiple motors. Well, those are taps, but they have their own specific rules in motors. Why? Because we know that motors can be sized differently, and they have different requirements for certain types of protection, right? All right. Anyway, rapid drop-off means I'm either confusing people or they're uninterested this morning. So I am going to thank everybody for joining me here for coffee hour on Tuesday. And I'm not sure how deeper we're going to go into secondaries. I'm definitely going to get the high bay one tomorrow out of the way. And then we might transition into something totally different. So again, just stay tuned and see where we'll be tomorrow. So we'll cut you loose early. Everybody, thanks for joining me this morning for coffee hour. Hopefully you got something out of it. It wasn't too confusing. I do go all over the place. And for those out there who say, I don't like that Paul goes all over the place, there is tons of other videos on YouTube. Check them out from other educators. Again, I do not, I live in a world where I do not twist anybody's arm to watch my content. You can agree to disagree, or you can love it. It's totally up to you. Till next time, folks, stay safe. God bless. Thank you, Dan, Eric, Paul, Red House. I see you there from Arizona. I see you in there. So, and everybody else that I might have missed, take care. Yuki, say hello to Schwartzy for me. Till next time, folks, stay safe. God bless.